Hi everyone. Today we are going to solve a problem where we're going to build an optimization pipeline linking together a scheduling algorithm to a routing algorithm. In particular, today we have this problem here. We have a retail business that needs to deliver items to some customers following a 5 days, 3 shift per day schedule. The business hired 4 independent delivery services that they have some preference. They want to work on certain days and certain shifts. So the business now has to find the optimal schedule to satisfy the requests, and it also has to find the optimal set of routes for each service team. So let's start doing this by importing the SDKs that we need to use here to solve the problem. You see that here I'm using the scheduling toolbox for solving the scheduling problem, and the routing toolbox for solving the routing problem. So let's go ahead and import the SDKs. Now we can start by creating the scheduling model. So I use the employee scheduler from the scheduling toolbox. I create a new scheduling instance. So as we said, we have 5 days and 3 shifts per day, and we're going to set up these parameters in our scheduling model. So we can proceed then to create our teams. Here you see that I've used a staff constructor. Staff is another name for team, and I add 2 employees. We add Mario and John, right? Each employee has a cost, $100 per hour, for example, and this team has a preference to work on day 1 and shift 0. And if we can find a schedule that satisfies their request, then we can get a discount of 10. Instead of paying 100, we're gonna pay 90. So let's go ahead and add the preference to the team here. So you can also see that we can print the team, and the team has exactly Mario and John. We can go ahead and do the same for other teams. Team 2, Team 3, and Team 4. Interesting here, Team 4 doesn't have any preference. The cost is 120, but you can work any day and every shift. So let's add the teams to the scheduling model. So now, to solve this problem, we can connect to the Parallel AI backend, and when we do that, we're going to receive in return an optimizer. Optimizer is an object you can use to run the optimization model, basically, the scheduling. Here. Let's go ahead, run the problem, and see we get the result back in 4 milliseconds. This problem is actually fairly easy, so it's pretty quick to receive a result. And we can see the result here by printing the schedule, right? So we have all the teams and all the schedules. And if you see for Team 1, we have Team 1 schedule on day 1, shift 0. This is exactly what Team 1 requested. If you see here, we have day 1 and shift 0. Similarly, for Team 2, we have day 1 and shift 2. Let's go ahead and check. Team 2, day 1 and shift 2. See, similar reasoning applied to Team 3, and Team 4 doesn't have any preference. So let's print the schedule now for the first team. See. Now we want to solve the problem of finding the best routes where to send these guys here on each shift, right? So how do we do this? How do we link a routing problem now to the previously solved scheduling model? Well, we can do this with a converter object. Converter is an object that basically converts the output of one problem to the input of another, right? So let's go ahead and start creating a VRP, a vehicle routing problem first. So we do this by calling the appropriate constructor, and then we create our converter here, you see? And when we create the converter, we can connect the scheduling model, which we just solved, to the new created VRP, like this. And you see that we print here an information that we have basically a total of 15 possible routes, because we have 3 shifts per day of on a 5 days week, right? So 5 by 3, 15. So now let's map the one problem to the other. We do this by mapping the trucks to the people driving them, right? So for example, for Team 1, we have 2 people, and we have 2 vehicles, right? Team 1v1, Team 1v2 here. Each vehicle has a certain capacity, 150 and 100. And each team also starts from a different depot, right? The starting location. So in this case, I'm just using a random number here, a random to the point where they start to deliver items. And you can think about using the SDK actually to give an actual address. The SDK will take care of determining the coordinates of the address that you give here to the SDK. So let's go ahead and do the same for Team 2, Team 3, and Team 4, right? So now we have to also set up the locations. So again, we have 5 days, 3 shifts, so we have a nested for loop. And for each shift, we have, in this case, I'm using 10 locations, right? A list of 10 locations. I use a random to the point again, and the demand as per vehicle routing problem. We have in this case, I'm using a random demand from of items from 5 to 15. Let's go ahead. So now, in order to solve this problem, we call the converter. We invoke the converter to run on the optimizer, and this is going to connect to the backend Parallel AI engines and run basically 15 different problems. Now this can be done in parallel. For the sake of this video, just simply run it sequentially, and you see that now it's calling the backend and solving all these problems. These are pretty simple problems, you see, very, very quick to solve. And now you see that we have all the problems solved here, so we can safely disconnect from the backend. We don't need to use it anymore. And now we can go ahead and print our scheduling, right? So you see that now we have basically all the solutions here. For example, let's take the first one, right? We have the route on day 0 and shift 0. This one here, right? And see that we have the route for each truck. We have 2 trucks, and here you see that it's 0. There is total distance 0, and this means that all the second truck can basically satisfy all the requests here. Total distance 31, right? Remember that route on day 0, shift 0, we have day 0 and shift 0, team 2. Team 2 has 2 people, so we have 2 trucks, and you have 2 routes, right? 1 for each truck, and you satisfy everything with the second truck here. Similarly for the other days, so we have day 1 shift 0, day 2 shift 0, shift 1, shift 2, etc. till day 4 and the last shift 2, right? 0, 1, 2, and 3. So I wanted to show you how to use in this video the Parallel AI SDK to connect different algorithms like building blocks. You can think about expanding this pipeline here by linking together, chaining together other algorithms, right? Or you can also think about running the same routing model like in parallel here. Maybe you want to use different algorithms to solve the routing problem, so you can do that by connecting the scheduling to multiple routing algorithms. I hope you enjoyed the video, and next time I'm going to show you how to expand this pipeline by connecting other blocks like genetic algorithms, so you have a more complex pipeline.